Today we're going to look at lesson 25, and your learning objective or I can statement is I can graph and do operations with complex numbers. So really we're doing, you could almost call it a whole complex number unit in one lesson. So don't stress out about having to do this all in one day. You can break it up over 2 days if you want to. If you want to get it all done in one day, that's fine too. It's really just up to you. But do know I'm going to go through this quicker in the video than I would in person, so you're welcome to pause and rewind as you need to. And you're welcome to go back and forth between the video and your Math Excel work if you want. But since this is like almost a whole unit in one lesson, we are going to do a few different parts, a few different things with complex numbers. So we will be switching gears every little bit. So first we need to talk about what a complex number is. So complex numbers are just made up of real and imaginary numbers. So there are two parts making up one number. So this is the form a plus bi, where a is the real part, it's a real number, and bi is your imaginary number. So this together is one complex number. Here are some examples of complex numbers: 3 plus 6i, 7 minus 8i, negative 3 minus 2i. Each of those are complex numbers. If you have your form of complex number, if b equals 0, then it's just a plus 0i, which is just a, and that's a real number. Okay, and we're used to those. We use those a lot. If a equals 0, you just have 0 plus bi, and that equals bi, and that's a pure imaginary number. Okay, so you can have just the real part of the complex number, you can have just the imaginary part of the complex number, but most of what we're going to look at today has them both together. So like I said, we're going to do a few different things with those complex numbers. Okay, next we need to look at the complex number plane. It's like a coordinate plane, except it's for complex numbers. So what we're normally used to as the x-axis is our real axis. So that's where you have your real portions of the complex numbers. Our y-axis is now the imaginary axis. So that's where we plot the imaginary part of the number. Now, we're going to plot them very, very similar to how we plot a regular ordered pair or coordinate point. So if I was to give you, and I'm going to use some different colors here to help you see where it's at on the graph. So if I was to give you 2 plus 3i, we will graph that. Like if we were thinking of it as an ordered pair, that would be like 2, 3i. Okay, so you would go to 2 on the real axis and then go up to 3i on the imaginary axis. Okay, and we'll do a couple more. So negative 4 plus 2i, so you go to negative 4 on the real and up to 2i on the imaginary. Oh, and I just realized that you can't see that. There we go. I'll go over it. There we go. That's better. All right, let's do another one. 1 minus 2i. So you get a 1 on the real, negative 2i on the imaginary. And then last, let's do negative 3 minus 4i. So you go to negative 3 on the real and negative 4i on the imaginary. Okay, so you're treating the real number like an x coordinate and the imaginary number like a y coordinate and graphing those on the complex number plane. Okay, next we're going to talk about taking the absolute value of complex numbers. So the absolute value of a complex number is just the distance of the complex number from the origin in the complex plane. So like if we're looking at this pink point, the absolute value would be the distance that point is from 0 or from the origin on this complex plane. Okay, so to do that, if this formula, it's the absolute value of a plus bi equals the square root of a squared plus b squared. Okay, that comes from the Pythagorean theorem, because you can make a triangle for that point. So you take the x, the distance of x, the distance on the y, or the real and the imaginary, and to get that diagonal, you do the Pythagorean theorem. So that's where this formula comes from. Okay, but you don't have to think about the triangle. You don't have to think about the Pythagorean theorem. You just take A, plug it in, B, plug it in, and work it out. So we'll do a few examples. Okay, so we're just going to do these 3 examples. So the first number is your A, and the second is your B. Okay, and you're not including the I, because if you remember, our complex number form is A plus BI. So on this one, A is 2 and B is 4. So you're just going to plug that into this little formula. So A squared plus B squared. So A is 2 plus B is 4. So that's 2 squared plus 4 squared. 2 squared is 4. 4 squared is 16. And so that gives us the square root of 20, and you have to simplify that. So going back to what we did yesterday, you can pull out a perfect square. You can do a factor tree, whatever you want to do. But that simplifies to 4 square root of 5. Okay. Number 2, we have 10 minus 5i. So in the formula, we'll have 10 squared plus negative 5 squared. And make sure when you're squaring a negative number, that negative has to go inside of the parentheses, especially if you're typing it in the calculator. So 10 squared is 100. Negative 5 squared is 25, so that's the square root of 125. Again, we need to simplify that radical. You can break it up. You can pull out a perfect square. You can do a factor tree, whatever. But that does simplify to 5 square root of 5. Okay, and then number 3, we have the absolute value of 12i. So we just do the absolute value of 12 squared. Because we don't have an a, so a is 0. So 0 squared is just 0. It doesn't matter. So the square root of 12 squared, you can do this either way. A square and a square root cancel each other out, so your answer is just 12. Or if you didn't know that, you could still do 12 squared is 144. That square root of 144 is 12. Okay. Oh, sorry. But that's all you do for the absolute value. Take A, B, square them, add them, take the square root. Next, we're going to look at addition and subtraction. It's very, very easy. You're going to add and subtract the real parts, add and subtract the imaginary parts. It's just like combining like terms. Okay. So on number 1, we have 4 plus 2i plus 5 plus 2i. So we're going to add the real parts. 4 plus 5 is 9. And then add the imaginary parts. 2i plus 2i is 4i. Right, number 2, 3 minus 4i plus 6 minus 5i. 3 plus 6 is 9. Negative 4i plus negative 5i is negative 9i. Okay, now we have subtraction. And so with subtraction, it's tricky because you have to make sure you're subtracting. All right, so negative 4 minus 2 is negative 6. Negative 3i minus 9i is negative 12i. And then 6 minus 2i minus 3 plus 8i. So 6 minus 3 is 3. Negative 2 minus 8 is negative 10i. Okay, 5 and 6 are a little bit different. You're going to have to simplify the radicals and create your imaginary number, and then do the addition or subtraction. So number 5, the first one is 5 plus, now the square root of negative 9. So the square root of 9 is 3, and you get rid of that negative by changing it to an I, plus, we've got 9 plus, the square root of 16 is 4, and you get rid of the square root of a negative by adding I. And then, I'm running out of room. So 5 plus 9 is 14. 3i plus 4i is 7i. Okay. Now, number 6, we're doing the exact same thing. It's just subtraction. So we've got negative 2 plus the square root of 4 is 2. Get rid of the negative and the square root by changing it to I. And then we have 6 minus the square root of 81 is 9, and we bring down our I. And now we're going to subtract. Negative 2 minus 6 is negative 8. 2I minus negative 9I minus a negative is plus, so that's plus 11I, and there's your final answer. Okay, next we're going to look at multiplication. And our multiplication is going to be like the distributive property and the FOIL method, okay? Some of our multiplication problems are really simple, but then some of them you're going to have to think like the distributive property and like the FOIL method. But we also need to know what happens when you multiply multiply I by I or do I squared. I is equal to the square root of negative 1. So if you square I, you're squaring the square root of negative 1. A square and a square root are opposites. They cancel each other out, just like addition and subtraction, multiplication and division. Those cancel each other. So the square and the square root cancel each other out, and we're left with a negative 1. So that means anytime you have an I squared, we're going to change it to negative 1. Okay, you cannot leave an I squared in your answer. Okay, so we'll start simple. We have 4I times 3I. I know 4 times 3 is 12. And I times I is I squared. I can't leave it like that. I have to change that I squared to a negative 1. So 12 times negative 1 equals negative 12, and that's my final answer. Okay, let's look at number 2. We have 8I times a negative 2I. So 8 times negative 2 is negative 16. I times I is I squared. That changes to negative 16 times negative 1, and that gives us a positive 16. Now, you don't have to write out all that middle stuff every single time. If you know that when you do I times I, it's going to give you a negative 1, you can jump straight to the end there. Whatever works best for you. Okay, 3 and 4 are a little bit different. We've got to rewrite those radicals in terms of I and then multiply them. Okay, sorry about that. I had a phone call. So we're going to have to rewrite these in terms of I and then multiply them. So the square root of negative 4, the square root of 4 is 2. Get rid of the square root of a negative by doing I times square root of 9 is 3. We'll have an I. 2 times 3 is 6. I times I is I squared. 6 times negative 1 is negative 6. All right, number 4, the square root of a negative 100 is 10I times square root of negative 25 is 5I. So that's 50 times I squared, which is just negative 50. Okay, number 5, we have 4I times the quantity, or times the complex number 2 plus 6I. This is like the distributive property. So we'll do 4I times 2, which is 8I. Then 4I times 6I is 24I squared. And remember, we changed that I squared to a negative 1, so that's 8I plus 24 times negative 1. And so that gives us a negative 24, and I'm going to put that in front, and then plus 8I. Okay, number 6, we have 2I times the complex number negative 8 plus 5I. So again, it's like the distributive property. 2I times negative 8 is negative 16I. 2I times 5I is positive 10I squared. We know that I squared changes to a negative 1. So that's the same as negative 16I minus 10. We can rearrange it. So negative 10 minus 16I. Okay, number 7, we have a complex number times a complex number. You have to do this one like the FOIL method. So first, outer, inner, last. So first we do 1 times negative 2, which is negative 2. Then we do 1 times negative 7I, so that's negative 7I. And then we do negative 6I times negative 2, so that's negative 12I. And then 1 times, oh, sorry, Did anybody catch what I did? On 6. Oh, that's what I did. Okay. Whew. I knew that something wasn't going to work out right there, and I wasn't sure what I was thinking. I apologize. Ignore that. So you do 6i times negative 2 is negative 12i, and then I was just drawing the arrow wrong. 6i times negative 7i is negative 42i squared. Okay, so now we have to do a couple different things. We need to combine like terms. So we have negative 2 and then negative 19i. And then we also know that this I squared changes to a negative 1. So that's negative 42 times negative 1 is a positive 42. Then we can combine like terms again. We've got negative 2 and 42. So that's 40 minus 19i. Okay, so you have a couple more like that where you just are doing the FOIL method. So you do the same thing every time. So first, outer, inner, last. When you do that last one, you'll have an I squared, so you'll need to change that to a negative 1. You should have like terms in the middle that you need to combine, and then you should have like terms again to get your complex number. Now, I'm not going to do another one of those because it's the FOIL method. You guys should be familiar with that. If you need me to do another example of that for you, just let me know, and I would be happy to. But we are going to move on and do one last thing with I. Okay, next we're going to talk about the powers of I. So we know that just I is the square root of negative 1. Okay, so I squared is the square root of negative 1 squared, which is just negative 1. So I squared equals negative 1. I cubed is I squared times I, because of the product rule from exponents. So we know I squared is negative 1, and I is just I, so that simplifies to negative I. And then I to the fourth is I squared times I squared. So it's negative 1 times negative 1, which is positive 1. So when you're simplifying the powers of I, this I to the fourth is really the key, because anytime you have I to the fourth, you can change it to 1. Okay, so we're going to practice simplifying powers of I. So if I give you I to the 16th, okay, how many times does 4 go into 16? 4. So I'm going to change that to I to the fourth, okay, because that's our key. That's our thing that we're going to need. So I to the fourth. So 4 times what is 16? 4. Is there a remainder? If I do 16 divided by 4, is there anything left over? No, just a 4. All right. So I can change that. I know I to the fourth is 1. So that's the same as 1 to the fourth, which is just 1. Okay. Number 2, let's do I to the 26th. Okay. So again, I to the fourth is what I want, so I to the fourth. How many times does 4 go into 26 evenly? Okay, 6, because 4 times 6 is 24. So how many are left over? 2, I squared. So we know 4 times 6 is 24, plus 2 is 26. All right, we know I to the fourth is just 1, so that's 1 to the 6th times, what's I squared? Negative 1. So that's the same as 1 times negative 1, and our answer is just negative 1. All right, number 3, let's do I to the 7th. And so 4, how many times does 4 go into 7 evenly? Once, so it's just I to the fourth, okay? And then how many are left over? What's the remainder? 3. All right, so we know I to the fourth is just 1, and 1 to the first is just 1. I to the third is negative I, so negative I. And if you simplify that, you just get negative I. Okay, so you have a couple problems like that in your Math Excel homework. You have we've covered a lot of complex number stuff in this one lesson, but it should help you do your homework. Again, break it up over 2 days if you need to. If you need more examples, just let me know. Send me an email. Hit Ask My Instructor, whatever you need to do, and I would be happy to help you. Have a great day.